Chrome, no? Oh, okay.
Oh, well.
Okay, so we're online.
Yes,
Hello, everyone. I'm here today with Gabriele to talk you guys about the Zetta Platform. So we're going to wait for maybe 1 or 2 minutes to make sure that everyone get a chance to join. And we are back streaming on X. So you can watch us and all of our webinar on LinkedIn, YouTube, as well as on X or Twitter, whatever you want to, you prefer to call it. Okay, as we wait for latecomer to join, what we're going to do is to share already the screen. So we'll get started shortly with the presentation. Okay, you should already be able to see my screen. And you are there too.
Yes.
Okay. Okay, what I suggest is that we start rolling with the presentation. And we've done a few webinars on Zetta. Today, I just want to make sure that you get a little bit wider perspective of how you can use our offer, which obviously includes the PaaS, but goes well beyond the PaaS. And let's start always with the problem, right? The problem is that today, more and more systems face with the problem of having to span from a microcontroller up to the data center. And this poses new challenges that there weren't before, because I would say that the past decades was mostly characterized by focusing either on a system level, that could have been a car, a robot, a ship, whatever, and then with some connectivity in some cases, but not in all cases, perhaps to a cloud. And the way in which the system are evolving is that, as opposed, they're becoming, I would say, more continuous and less discrete. Okay, so there is computing a little bit throughout this continuum, and you have the necessity to all of a sudden, manage infrastructure applications that are running and that are deployed in this continuum to deal with the communication, to deal with the storage, to deal with the computations. And again, this is a cross-industry challenge, because you have these challenges in robotics, because a robot, as we have seen several times, you have plenty of microcontrollers, right? You have high-end a computer, depending on the scale of the robot. You might have infrastructure on the edge and potentially up to the cloud. The same is true for automotive. The same is true for IoT, and so on. You name your domain. The same is true for medical. I mean, I could continue to list application domain. Now, when you try to build this system today, typically you end up with something that kind of resembles to a digital Frankenstein. Why? Well, because usually you have to glue different solutions, even if you're starting with a greenfield deployment, as we will see in a moment. I mean, before Zetta, before Zenoh, as we will see, you had no choice, right, but having to integrate multiple technologies in order to be able to have your system span from the microcontroller up to the data center. And this was making your life harder than it should have been. And what is the solution? If you have seen some of our previous webinar, there are really two axes to the solution, right? There is a technological solution, and as you might know, there is Zenoh. And then, a technology alone, it's great because it gives you a core building block for the solution, but then there is all the surrounding to making that technological solution a platform that is productive in order to solve the problem that we are trying to solve. So in terms of technology, Zenoh solves this problem, the problem of supporting the development of applications that span from the microcontroller up to the data center, because it was designed for this. It has proven itself in this domain. We have lots of customers running it literally from Arduino, even smaller devices, through workstation grade hardware up to the data center. But more importantly, it addresses the three key elements of distributed computing. With Zenoh, you can move data around, right, through PubSub. You can represent distributed computations, and you can have distributed storage, which again is very powerful, especially at scale, because it's unthinkable that you push all the data toward the data center and store it in a centralized manner. All of this is provided by guaranteeing and still ensuring location transparency, not only for PubSub, but also for computations and for data storage, which is game changer when building distributed systems. Other important aspect is that sometimes is a kind of not very well known feature of Zenoh. Zenoh supports zero copy, which in some of the robotics, medical, or automotive environment is very important, especially when you need to do high performance pipelines, sharing data efficiently, in that case zero copy, over shared memory, and perhaps doing processing over images or anything alike. Could be a point cloud and so on and so forth. Now, Zenoh actually is the protocol, but is also one of the implementation of the protocol. And so to avoid confusion, when we refer to Zenoh, there is this ambiguity because we might be referring to the Rust implementation, which is the reference implementation and probably the most widely used implementation of the Zenoh protocol. And then there is another implementation that targets microcontroller called Zenoh Pico. So the Zenoh implementation of the Zenoh protocol is written in Rust, as shown in this slide, and provides you API in a plethora of programming languages, from C to Go, including TypeScript and JavaScript, as well as Kotlin, for instance, if you are doing Android development. And the Zenoh Pico implementation only provides you with C and C++, because that's usually what you would use in an embedded systems. And there is portability between C and C++ application across Zenoh and Zenoh Pico. And obviously, the two implementations are fully interoperable. And in terms of feature or protocol semantics or Zenoh semantics, they are equivalent. The only difference is on the topology that are supported, and I'll get there in a moment. Supported OS. Essentially, Zenoh Rust runs on anything where you can run Rust. And in addition to that, we already target several embedded platforms with Zenoh Pico, like Arduino, ESP32, Mbed, Zephyr, FreeRTOS, a few more. The full list, I believe, is on the Zenoh Pico GitHub repository. And adding a new platform is usually quite straightforward. We also support some automotive target. So as a company, we provide support for Vector AutoSAR Classic implementation, but there are other companies that provide support for other AutoSAR implementations. So the protocol was designed to be able to run at data link level. That's very important when you claim or when you want to address the microcontroller to data center spectrum, because again, on the microcontroller, maybe you don't have an IP network. Right? Maybe you're running on a radio link, actually on a sound link. Those are very constrained. Sometimes you cannot afford to have IP. So assuming that we are running on top of data link, allow us to run almost on anything. And then as a consequence, then Zenoh has to do its own routing, which in any case, we do even on top of IP, because we route based on named data, right? IP routes based on IP address. And that's one of the source of challenges with host centricity as opposed to data centricity or name centricity. It's very efficient in terms of wire protocol, just a handful of byte wire overhead. And the other important thing is that a Zenoh runtime can use multiple links at the same time. So you could have an application that is running over a satellite link, quick, TCP, and perhaps serial concurrently, and even routing between and across them. So in terms of topology, obviously, if you want to be able to scale and cover the requirement of application that span in this continuum, you can't afford to have topological restriction because they will reduce your applicability, right? And as a consequence, Zenoh can operate over a click, so the full peer-to-peer assumption or DDS, over a mesh, and in fact, also in a brokered or routed environment. So this is an example of one of the topology that can be supported by Zenoh. where some application might even take the role of a client, and in that case, they will need an infrastructural node, such a router or a peer, to allow them to communicate with the rest of the system. Now, getting back to Pico, the difference between Zenoh Rust and Zenoh Pico is on the topology supported. And in fact, Zenoh Pico can only do peer-to-peer under the assumption that you have a click. Why? Well, several reasons, but the most important is that we don't want to redo a routing algorithm in C. We don't think it's applicable for an embedded scenario because we are really targeting very small devices. And in most of those situations, a click just works sufficiently. And if you have to deal with mesh, like in the case of Radio Link, in that case, it's highly likely that you can deploy a Zenoh router as of today. Zenoh router, which again, whenever we say router, people think about a Cisco rack. No, right? It's very lightweight. You can run it on Raspberry Pi 2, okay, not even 4, which is a supercomputer in a way. And the other importance of our infrastructure being written in Rust, I won't be too tired to remember it, is security. 70% of the security bugs come from memory mismanagement, and Rust just slashes all of them because of programming language features. Other important element, before we move to the next axis, which is non-technological but is more about the platform, is the plugin. So Zenoh provide a plugin framework to plug third-party protocol. So we already have a plugin, as we will demonstrate, for DDS, MQTT, REST. We've done customized plugin for ROS2. But you can also plug databases. Okay, so we have already off-the-shelf plugin for some time series like Influx, NoSQL databases like RocksDB, S3, as well as file system and memory. And the important thing is that you have, by default, two ways of extending Zenoh. You can plug new protocols, okay, and transparently have Zenoh application interoperate with DDS or MQTT. But any protocol that is plugged into Zenoh, on theory, can interoperate with each other. So if I have a DDS application and MQTT application, I could do PubSub through Zenoh across DDS and MQTT. Or I could have some applications that are running on Zenoh, other on DDS, other on MQTT. So that's one way that Zenoh helps you building system. And as we will see, this is essential when you are building a system out of a brownfield, okay? The other way of extending, obviously, is adding new links. So you added, for instance, a couple of links, right? Serial, WebSocket, I think.
Serial, WebSocket, and MTLS in quick.
And that's pretty straightforward.
That's 1 week.
Exactly. So
if you don't know the code, if you know the code, it might be 1 day.
Yeah. So those are the two dimensions which you can extend Zenoh. But Zenoh, again, is the technology, right? Imagine, again, you are building a system that spans from the microcontroller up to the data center. How are you going to deploy the router? How are you going to secure them? You might need plugin. How do you make sure that the plugin are in the right place, right? Built for the right version. And how do you manage all of this complexity, okay? In order to do that, a technology alone, it's the starting point, but then there is quite some work that you would have to do, which you can do if you want. But ZetaScale has done it for you, okay? So I want to, again, emphasize the difference between a technology and a platform. So Zenoh is the core technology that we invented to address the challenges of communicating, storing and computing in the cloud-to-microcontroller continuum. And that's essential because that will allow us to make the cool things that we do today. So you can use this technology at the core of your platform for supporting your system. But again, usually that takes you away from your core business, which is perhaps building cars, building robots, or doing other cool stuff. The plumbing is our job, okay, in a way. And this is why the Zetta Platform is there. The Zetta Platform provides you with the ideal solution to support you during the development, the integration, right, the deployment, the operation of your system that span, again, in this continuum from the cloud to the microcontroller. By what is composed that Zetta Platform? Well, we have the platform as a service, okay, which is the Zetta Platform as a service that supports you through multi-cloud deployment. So by default, as we will see, you can provision on EC2, but in fact, we're independent of the cloud, and there is this concept of bring your own infrastructure, as we'll demonstrate. And you can deploy infrastructure down to your devices, essentially, and then monitor, manage, and secure from a single place. Then we have the Zetta router, and these Zetta routers are a key element because this is what allows you, again, to have a topology that ideally supports your system and through which communication is optimized. Then you have the connectors, and this is what connectors like protocol connectors for DDS, MQTT, or database connectors, as we were seeing before, are essential because, first of all, they help you with ecosystem. So you can decide to use Zenoh, but then if you have some partner that have already some portion of the IP that they need to integrate with you that are using MQTT or DDS, or you name it, either there is already a connector, or you can write a connector because the plugin API is open, or you contract us, we'll write a connector for you, no problem at all, okay? But you have a very clean way of integrating and making sure that everything works together. And anything that is integrated, as you will see, can be integrated up to the visualization, right? As we will show in the demo, okay? And then you have tools like Zetta C2, which we'll also demonstrate, which even offline can help you not only monitoring and visualizing your system, but also actually doing deployment if you have a full on-premise solution, for instance. And then the programming API. And again, in terms of programming API, if you're using Zenoh, well, you've seen we have a plethora of API, but you might, in some brownfield deployment, as we will see, have to deal with, well, let me call it legacy, without anybody getting offended, okay? But you might have other protocols that are being used, and you can use those protocols in your favorite language as far as you have a connector. And if there isn't a connector, you just do it, or we do it.
Yeah.
Okay, so what does this mean for a greenfield development? So if you're doing greenfield, so if you are one of those lucky guys that can start from scratch, then all of a sudden you have the choice to use Zenoh from the microcontroller up to the data center, on mobile, on web app, on everything, right? We run on Android. You can build Zenoh for iOS. I think if we do the robot demo, you will see web app that use the Zenoh REST API. But nowadays, I would use TypeScript, right? That's more efficient than the REST API and more user-friendly. And besides that, then you have the Zetta Platform as a service that makes it very easy for you to secure your infrastructure. So how are you going to manage certificates, okay? Access control, and so on and so forth. How are you going to configure this? To provision, manage, and operate your infrastructure, and require you with the scale to operate and actually manage the system at internet scale. So this is, some of you might be in this position and are lucky enough to be able to do greenfield development. And still, if a third party comes, suppose your system now needs to integrate with a client that absolutely wants to use maybe gRPC. I'll just give you an example. Well, you could do that through a connector. MQTT, likewise, okay? Now, if you have a system already, and you say, oh, okay, we are using a technology to communicate with a microcontroller. That's a bespoke technology built in-house. We just want to get away from it. I've heard about Zenoh. Sounds pretty cool. Zenoh Pico would be a perfect candidate. But we are using this protocol XYZ on the rest of the system. What do you do? Well, actually, our connector helps you to do that. So you can continue to use DDS, MQTT, or any other protocol in your system, as well as part of your development, while using connector, right, to unlock the use of Zenoh where it makes sense. Microcontroller could be one. R2X communication or V2X, so communicating across either a wireless network or across the internet, is the other use case that we will demonstrate. For instance, if you're using DDS in your system, it's known that doesn't mix well with wireless network. So in that case, I could use Zenoh, not even as a protocol for which I program application, but just to deal with this problem. And this is one of the way in which, for instance, is used in ROS2. But we have, for instance, ROS2 customer that started bridging DDS traffic over Zenoh for the Wi-Fi and the internet, but then ended up writing all new application on the cloud side in Zenoh because of the more API, because of much simpler programming interface, and so on and so forth. So even if you're not starting from scratch, there is still lots of value that you can get. And more importantly, Zenoh was designed with the recognition that if you're a new protocol, you will have to integrate. Okay, why? Because you're new, and eventually it won't be so new, and you will have to integrate even more. So in the design of Zenoh, integration was one of the requirements. Okay, that's why it usually is so easy to integrate a different protocol and data storages with Zenoh. And so just to understand, right, I could have, as we will see, some application that are running MQTT, Zenoh, and DDS, and still have that data stored in a Zenoh storage, right? Okay, so if we take a greenfield example, just to visualize this, right, I could have robot fully built using Zenoh from the microcontroller up to whichever level of hardware they're using. I might still keep some storage decentralized straight on the robot that I might query from anywhere. I might have, I'm building next generation car. I might use Zenoh on that, right? Some kind of machinery, industrial machinery. Those are examples. So in any case, you have Zenoh, as you see in the background, running all throughout the entire, spanning throughout the entire system, up to web application or mobile application, whatever. Okay. So this case, it's kind of, I would say, straightforward, and obviously it's supported by the Zetta Platform. But the world often, is more complex. So it's likely that maybe a new product will be using Zenoh, will be full-blown Zenoh, but then, some other product line or some other system, they are validated. Why change if it works? But you still need to integrate. And so let's go one by one. I might have, in this case, some vehicles that are using DDS on vehicle, okay, and MQTT for V2X. And then the question is, well, can I use Zenoh? Of course. And in fact, you could even use Zenoh to scale MQTT, because we could have an MQTT plugin on any of the router that, in this case, are running on maybe 5G cell or access, yeah. And in this case, right, you would be able to scale and even route through Zenoh between different MQTT brokers transparently. And as you will see, even in terms of cost, in a far more effective manner, because we won't charge you for high availability. It's just a consequence of the nature of how Zenoh works, that you could get both replication as well as, let's say, better scalability. So in this case, you see that you're using Zenoh integration with MQTT, and the rest of the system is remaining the same. And potentially, I could use then this to have some coordination between my robot and my autonomous vehicle. Okay, for instance, autonomous vehicle comes, the robot changes the wheel. Okay, one example. In here, we have yet another case in which, and this is actually not pure fantasy. Neither this is pure fantasy. Okay, but if you have industrial machinery, there are few industrial machines that are using DDS and that are actually using Zenoh to do vehicle-to-vehicle communication and vehicle-to-anything else communication. So that's another case in which you would simply drop, as we've done in ROS, a Zenoh router or a bridge, which is just a special build of a router, with a DDS plugin and told Zenoh everywhere else. The same principle applies at every level in the system, but the key point is that thanks to this plugin, you can choose to maintain what you have, you can easily integrate, and more importantly, you can leverage Zenoh wherever it makes sense. But there is something more. Imagine that now, I want to, as I said before, get rid of my bespoke protocol that I use for embedded devices. I could still use Zenoh on the microcontroller and still, through a Zenoh plugin, have that communicate with DDS. But we can do even better, because if you have DDS and you're using our DDS implementation, so Cyclone DDS or Zetta DDS, then actually you don't even need to bridge. Our Cyclone can talk natively Zenoh. Okay, so in that case would be just perfect situation. You don't even need to add an extra hop. Because in terms of latency, I mean, it's marginal, but that could cause a single point of failure that, especially in safety critical application, is not acceptable. So the good news is that for some specific technology, and for instance, the technology we develop, then you have native interoperability, which is great. Okay, so moving to a comparison, I mean, there are more dimensions. We'll probably add some more details, because I think there are a few other points worth investigating. That's really the summary of the summary of the summary of the summary. Okay, so but to put it short, if you compare, for instance, Zenoh and the Zetta platform with Kafka, MQTT, and NUTS, then that's the only solution that was really designed to go cloud to microcontroller. Is the only protocol that can really do that. In terms of energy efficiency, it goes really beyond anybody else, and there were several studies that were published on this aspect. All of those provide a platform as a service, but I think in that, I think we are the one that have most flexibility with respect to bring your own infrastructure. I'll let you fill in. Performance, NUTS is high performance, but we have a third-party benchmark that shows that, at least in the use case that they looked at, Zenoh is even more performant. Then obviously all of those can be cloud native, but the only one that is really edge native is Zenoh. There are some other aspects, right? We provide more connectors to databases. We provide more connectors to storages.
Well, sorry,
to protocols.
Exactly.
And then, I mean, what else? I will let you fill in.
We also provide, I mean, as you said, we provide very easy integration with bring your own infrastructure. Because if you look at NUTS or EMQX or IvenQ, you want to provide your own infrastructure, there is not even a price. It's plain contact us and you will know more how to do that. While in the case of Zetta, you can easily bring whatever, let's say, Kubernetes deployment you have. Can be on the cloud, can be on premise, as we are going to show, can be on, let's say, on a car, on a robot, whatever. And in that way, we can very, very easily, just a few clicks, deploy on your cloud, on your edge infrastructure. And that comes also from the edge native part. Because we are able, to the end, thanks to Zenoh, and we are doing some dog food in there to communicate with whatever infrastructure, no matter where it is. And we can easily, very, very easily deploy on that, and that simplifies.
No need to set up VPN. No need to anything.
I mean, it's not only deployment. You can also see what's happening on your edge infrastructure, because we are able to get out the monitoring for the router that you are going to deploy. You could see them directly on the platform without needing to, you need to call my IT department. We need to agree on a port to open. We need to agree on the sharing of the secret on AWS, and so on and so on. Just a few clicks, and you can do that.
Done.
While with the other ones, a bit good luck. And apart from that, we also provide very simple. I say we have the same level of API that the other platform provides, and we're working hard in order to provide an API in order to integrate in general with the platform. So not only, let's say, use it from a dashboard, but we understand that customer may need to integrate with their own system, because they may want to deploy router, let's say, on demand, not only, let's say, by clicking an infrastructure there. So the idea there is to have an API that also simplifies this deployment, but again, not only on our AWS, let's say, but also on their premise. And ideally also have an API, it's a kind of an SDK from which you can simply, through your application, connect directly to the cloud project that you just created. You just fill in an API key and your application can connect without needing to think about, I need now to pre-provision certificates and so on and so on. You can just pre-provision an API key, and that way you can very easily connect to your cloud infrastructure. Your edge infrastructure depends where it runs.
Okay, good. Pricing, because I think it's also important, right? So going back to your point about your own infrastructure, there are two different pricing, right? Because by default, we provision on Amazon EC2. And in that case, obviously, we pay Amazon EC2. So necessarily, you have to help us paying that too when using Zenoh in a way, or you get part of that bill. in a way, and we'll get there. And our prices are fairly open. Usually they are once you log in on the Zetta platform, that's what you see. And they're pretty competitive. So we will let you do the analysis with the other provider, but you get better performance at lower price, which I think is a pretty good deal. But it's even better because what you can do then, if it makes sense for your application, is to start deploying on your infrastructure. And in that case, the price becomes even more convenient, because all of a sudden the charging reduces, right? Still pay as you go, but at the same time, you might reduce massively your operating cost, because by decentralizing your infrastructure, then in a transparent manner, okay, because you can calculate how much it will cost, and if you're outside of these quotas, we're fairly reasonable, but you can constrain communication on-prem, which means you won't be paying egress out of Amazon, okay, which is good for the planet because that burns lots of energy,
Exactly.
and good for you because you gain performance and availability for your system. Okay, so at this point, I think let's
play with it.
Yeah.
Okay.
Or you know what? I will do the final remarks, because then we never get to the slides and then we play with it. So we kind of do it weirdly this time. Okay. So in summary, and then we'll move to the demo. The Zetta platform provides you, with the ideal solution for building your next generation system, as well as incrementally expanding your existing solution, as we've shown. And it is the integration, and make sure that even in your brownest field application, you can still have a path toward embracing Zenoh and embracing the kind of technology that we have shown, and leveraging the power, both in terms of flexibility as well as in terms of productivity. If you're not familiar with the Zenoh API, just take a look at it. I mean, we have put huge amount of effort to keep it extremely simple, orthogonal. And we are always impressed by how much people do. In fact, they build entire system without asking questions. And sometimes on our Discord, they say, hey, this is what we built exactly. And I say, okay, great, wow. Great. And again, the core technology is open source. That's an Eclipse project. So that's, I think, another pretty powerful and important aspect to raise. That said, let's take a look. My screen. Just give me a moment. We'll move to your screen. And we are seeing your screen.
Okay, so what we are seeing now is actually, let's say, the login page for the platform. So what I want to show first is, say, the platform, of course, and also one of the aspects that Angelo already talked about, which is the integration with other protocols. So first thing first, let's connect to our platform. And as you can see, we have a bunch of Zenoh deployment running, actually. As you can guess by the name, one of those deployments involves MQTT. Some deployment have multiple regions, and some deployment are just one single region, and a deployment is called local, and we'll see later why. So let's start by integration with other technologies. So I have this project, this demo project, which includes a router in Frankfurt. And this router, in this project, as we can see, there is a ROS2 icon on my left. What that means? That means that actually this project has a robot connected to it, which is actually this B072, is like a lit name for our bot number 2. And this robot is actually running DDS. So it's running, in this case, Cyclone DDS with plain ROS2. And we put a bridge on it because we wanted the communication for the robot to not go over Wi-Fi. We don't want the DDS over Wi-Fi because that's usually produced.
So that's exactly the example of the excavator that we had in the slide.
Exactly.
Yeah? One-to-one.
So instead of being an excavator, this is kind of a Roomba robot, but the concept is the same.
Exactly.
And what is interesting there, you already seen that there is some data going out. You will say, yeah, but where is this data going? Actually, this data is going to this page. This page, we are using the Zenoh REST API to retrieve some information from the robot. In this case, is the LiDAR scan, and we could also drive the robot. And as you can see, while I drive the robot, the LiDAR moves, which is actually, I'm actually drive the robot. If anyone wants to try...
Yeah, we should try to show the robot.
You can try to show the robot.
Okay, you can move.
So if I'm moving the robot, and as we can see, the robot moves. Let me
go.
Yes, that way. And then let's go back. And actually, the robot is moving, and I'm controlling it from the cloud in this case. And as we can see, we are receiving the LiDAR quite very low latency. And all of this, in this case, we are bridging between Zenoh and DDS in a seamless manner. But I mean, bridging the data, I will say it's nice. I mean, it's a very useful use case because we could all of a sudden, as Angelo said, we could have different technologies in all our system, and so we don't need to deal with the digital Frankenstein. We could have a greenfield and brownfield system that works together. But what if I want to see what is actually happening in the robot? For instance, what it is the ROS graph? Well, we can do that. And I want to point out that we are doing it from the cloud. So I'm connected to a website, and all of a sudden I could see the ROS graph of this robot. I mean, it's not a huge ROS graph, but it's already complex enough. And from that, we could see every topic, for instance, in this case, the robot state, to which topic is publishing and to which topic is subscribing, and so on and so on. And what else we could do? We could also see them with a list view if we are looking for a topic, I don't know, like CMDevel. It's not called CMDevel.
It's called bot2.
Bot2.
Yeah, it's slash CMDevel.
No, I think it's not called CMDevel. That's nodes. My bad. It's there. Exactly. There we have the CMDevel. So I was looking at the nodes instead of looking at the topics. And when looking at the topic, of course, we get all the information that are important for a ROS2 user. So we have the name of the topic, we have the type of method that is being publisher, that is being subscribing in this case on this or publishing this topic, and we can also see who is publishing and who is receiving and who is subscribing to this topic. So in this case, we see that motion control is a subscriber, so that's the node that is actually moving the robot, and there is a teleop node, twist joy node that is publishing on this robot, which means that if we click there, we could see the point of view of that node, not only from publisher, subscriber, but also from a graph point of view. So we could see that this node is publishing and subscribing to a set of topics, and also we could see where those topics are going to. So we could see, as said, teleop twist joy is publishing on CMDevel that is then subscribed by motion control.
Yeah.
This is a very simple way to actually inspect what is happening on your system, even remotely, without needing to be there and connect. So what else we could do?
And by the way, as we do it for ROS, we could do for any DDS application, right?
Exactly.
Or Zenoh application.
Let's say ROS, we take ROS as a first-class citizen in Zetta. Why? Because there are a lot of our users that use ROS, and there are some tweaks that we need to do compared to a normal DDS application. But the same thing we could do with any DDS application.
Yeah.
So we can,
and for ROS, we'll continue to be able to show the graph even if you're using the Zenoh RNW.
Exactly. Even if you use RNW Zenoh, we are able to extract the ROS graph, and so we are able to see the same information, which for a user means that they can just change the environment variable, use the other RNW, the RNW Zenoh, and then all of a sudden they don't need to change the tool, they don't need to change anything.
Exactly.
Things just continue to work. What else we could do? I say we are already inspecting. Oh, we lose. Okay. The subscriber sometimes if it goes out, but I say we were monitoring how much data was gone through. We could actually see more detailed information, for instance, about our router in Frankfurt, which means we could see actually what is running. As I said, as Angelo mentioned, everything we deal with everything that is about security. So all the routers that are deployed by the platform or by Zetta are usually deployed using TLS and Quick, and actually with mutual authentication enabled, which means that your data is secured. You get only the clients that you configure with the certificates that are generated can connect to it, and we can either generate the certificate for you, or if you have a certification authority, you could bring your own certificate directly. Of course, then you have to be careful with the domain names, but that's part, let's say, of why we are able to generate certificate and simplify the life of users. And of course, we can inspect what kind of sessions are connected to this robot, and we could see what kind of topics are being published and subscribed, or there are queryable for one of this robot. But as we can see, actually, we are not getting the topology only for the things that are connected to the cloud. We can actually see that the robot has another device connected to it. In this case, we are extracting the topological information thanks to Zenoh in a decentralized manner, and we actually show that we have a Raspberry Pi that is more or less there, that is discovering the robot, and this is connected to the robot. And actually, this device has an MQTT subscriber, which means that if we have an application, if actually this subscriber is subscribing to some data coming from the robot to control a lamp, and this shows actually, as Angelo said, the integration between different protocols thanks to Zenoh.
And by the way,
and now Angelo connected something because now we can see the tool on his that is this tool there that is Angelo device that just connected, and from there we could see that we just get the topology right after. What else we could do? We could, again, of course, in this case is a cloud platform, but I mean,
I'll disconnect.
You disconnect?
Yeah.
Okay. Another thing that we could easily do, we can inspect how much data is going through. So for example, I'm showing the project metrics, which is the metric about how much data you're sending on your on the cloud in this case. But this is not only for the cloud. You can also get, we'll see with the Zetta C2, you can also get from local routers. So that's a way to integrate. But this is with ROS/DDS. Let's do something with MQTT. So here I have my Zenoh MQTT demo. I have nothing connected to it. So actually what I did, I downloaded a simple MQTT, let's say UI client, and I configured it to connect to our cloud. So I will connect to it and disconnected. And now I'm not receiving so far any data. And what I want to do...
Do you want me to publish something?
Yes, please.
Okay, but hold on.
I sent you have the configuration.
Yeah. You just have to give me 30 seconds.
Actually, now this MQTT application that, of course, I took especially a third-party application to show that whatever MQTT application that respects the standard can
keep
work.
Going while I set it up. Yeah.
And this application actually is connected to our cloud infrastructure. We cannot yet see there is something that we are working also to show the MQTT clients that are connected. But all of a sudden, what I could do, and actually something that I can publish just from my cloud. So let's say demo. Let me first create a subscriber, otherwise not getting any data. So I would create a subscriber on demo/pound, which means everything that starts with demo in the MQTT, let's say, jargon. So now I have a subscription. Here we have some historical data that I used before. So let's do a demo from cloud, and I want to publish an hello world. And I will submit. So I publish, and we can see that I actually immediately received the hello world on my MQTT application, which in this case, I said, we are publishing directly from the cloud. But we could take a simple application like a normal Zenoh application or a DDS application and get the same result. This is not only shows that we can easily bridge between the protocol, as we already showed also for DDS, but also simplifies the integration, as I say, between brownfield and greenfield deployments, because we can imagine that for the lucky people that can have greenfield projects, they could just get starting with Zenoh and use all the feature of Zenoh directly. But we understand that there are people that have brownfield deployments in which, for instance, they have a plethora of MQTT devices that they cannot get rid of. So, but in this case, what they could do, they could just replace their MQTT broker with a Zenoh router with the MQTT plugin, and all of a sudden, all those MQTT devices can also talk with Zenoh application. But okay, I can also publish. Meanwhile, that
because Discord was updating. Okay, here we go.
So okay. Then let's wait Angelo to publish, and in the meanwhile, I will also connect my tool.
So I can publish. Do you want me to publish from an application or from, because I can?
You can do
from the tool.
You can do from the tool, and we will see.
Okay.
So as I also started our offline tool, so I also started Zetta C2 because I wanted to show you actually. And I will create also there. I have already a subscriber on demo ** that we can use also to see that the data is being bridged again between both subscriber. The DDS, the Zenoh one, and the MQTT one is going to receive the data. There is some data there from some previous test.
I'm going to do slightly differently. I'm going to do like this. I just create a new conf.
So in the meanwhile,
here we are. So you should see my tool connected to the project.
Now we see actually there are two tools connected to this project.
So what topic have you created?
Well, demo ** everything that is demo ** should work. I need to change this one. This is again. Put.
Okay.
And actually, let me go back to my data part.
I'll publish. You are subscribing
demo ***.
Okay, so it'll be.
I'm subscribing demo ** to both. We immediately got it. So
what did you get?
We got ciao from Angelo, and we got it actually on MQTT, as we can see on the left, and on Zenoh on the right. Which this means that actually we are sending the data to both protocol immediately after they are being published. And now, if Angelo publish another another message with the same topic name, we are going to get it.
What did you get?
That's so cool.
Indeed.
Indeed.
It
I mean,
is.
we are doing it live, and as you can see, in this case, all the
Maybe
data
I should
is...
show I'm doing it right, because
I also wanted to try another thing.
sure.
We say
you publish
that
and subscribe.
no, I wanted to store this data, because we say
Sure,
that
of course.
no matter the protocol, with Zenoh we can
Yeah.
store the data. And actually, I will take advantage of showing the fact that we can store the data, showing another feature of Zetta. I say we can easily deploy on our machine or on a Kubernetes cluster, if we have one available, directly from our tools.
Yeah.
So what I did, I actually create a configuration. This is my local MQTT.json, which is it's a Zenoh configuration that of a router with a storage. So what I'm going to do, I'm just connecting it, creating it, and which means that all of a sudden we had an on-premise that appeared on my tool. And as we can see now, we have a local storage router.
So I will make some, and that's on demo star, right?
That's on demo star, yes. And actually we could see that he has a storage on demo star, which means that if we now publish, we are still going to get the data live. I say store it, and now we could actually fetch it. So let me remove this subscription, and let me actually do a periodic get.
Then I'm going to do something like
star.
Okay.
And I want to do every 30 seconds. Save. And we have demo greeting with store it.
And then if I update
if you update it, in this case, I create not a time series storage, but a last value storage. So which means that the data that is going to store, we are going just to store in the last value that is being updated, store it again, and then once this refresh every 30 seconds, once it refresh,
you know what? I'm going now to do some publication from a native Zenoh application.
Yes.
Right, because we could be cheating, right?
Yeah,
how do they know that we are publishing this on Zenoh?
Now we got
tool?
the story again.
So maybe we could. So are you going to do, or am I going to do it?
I can do it.
I have already let's actually generate a configuration from the past, right? So
okay. So let's see. I have this project, as I say, this which we can see already all the things connected. What if I want to connect another application? Nothing more simple. You can just go on the use my project here on the left. Click again on use my project, and then we can generate a client application.
Yeah.
So let's call this client application publisher, because I don't have any fantasy publisher. And in this case, I have a single router, so it will be connected to this router, and click next. By clicking next, this will use the platform to generate us again all the certificate and all the configuration that we need, and we get this nice overview to what to do next. I will just copy this, and I'm sorry, I'm going to open my VS Code. That maybe be not the nicest thing ever. And I'm going to create a folder, and I'm going to download my configuration and unzip it. And we are going to inspect what there is inside. So there is a README, and actually this README explains all the steps that we need in order to run this application. And we have a config.json. Let me just format it. And in this configuration, we have everything to connect to the cloud routers with the client mode. In this case, I configure the client. And also, in order to simplify life, we have inline certificates so that we can just copy this file and use it everywhere. What actually I'm now going to do, I'm going to use one of the examples that they also come as part of the package. And I can do a zpub.c config.json. And now this is publishing data. So we see published from 0, 1, 2, 3, and so on and so on, which we see that we are immediately receiving from...
I'm going to create a subscriber, by the way.
Yes. We are immediately receiving also on MQTT, and actually if we add also a subscriber locally to demos.
And I'm receiving the data. And so in the query, you will see data, and you will see now that I have two applications connected.
Yes, so now if we go to the home, we see a plethora of applications that are connected to our router, and we can actually see the data, where the data is going. So we can see that actually there is an application publishing here 79 something that is publishing, in this case, to the cloud because we connected directly to the cloud. There is a storage that is receiving some data because it's storing it, and there is the other application that is Angelo application that is subscribing. What else we could do? We could just move this application to the local router, and we'll see that we are still going to get all the information. So let's just do this. In this case,
I will also start a publisher. I will publish something else.
-e tcp/27001. 447. Nope, wrong command is minus. Okay. Okay, I need to change a configuration because I'm listening to, well, but that should work anyway. Oops. -c config also. Okay, my bad. Okay, let me do something. Let me stop this router because this router is listening on TLS. It should actually listen on TCP for me to connect without certificate. That's actually show that if you have certificates, then you cannot connect. That's part of the deal. So let me change those listen to TCP and UDP, and let me restart this router. So we can see that it's very easy to start and stop routers using Zetta C2. I will confirm. Now we have my router running again. So again is there, and now I can connect. Yes. Now connected, you can see that I have another device that connected, and all of a sudden we can see that there is data going through because there is still Angelo subscriber. And actually we see also that the MQTT client is still receiving the data.
And there is also now my new publisher.
Yes, and I can see is this one is the hello from Zenoh Python app.
Exactly.
So as we can see, we can actually see where the data is going. So we could see actually that there is this publisher, then there is this router in which we are also storing the data, and then we have another publisher here and another subscriber there, and of course also our MQTT subscriber that is local.
Exactly.
And we are on all of them. We are receiving the data.
Yeah,
which is quite neat because we didn't need to do that much configuration. We just connected a few things. We downloaded a configuration from the cloud and we just use it.
Yeah. The only things that you have to do is make sure that you use the same data serialization, deserialization.
Exactly. In this case, it's plain text, so it's fine. But you know what we could do? We could also, where is my data? There. So let me go to the storage. Let me actually publish also from MQTT. Because we could do that.
Of course.
Let me publish this. I don't want to publish a JSON. I want to publish a plain text. Let's publish hello from, always call this thing MQTT.
On which key are you publishing?
On demo slash from MQTT.
Okay, cool.
So I published that. We can see that it's already there. And once, we also see there. Oh, sorry. Yes, we see. No, yes, there. We see that we are already seeing demo from MQTT, so it got stored in the storage and is also it's not on the subscriber. That's quite strange, but it's actually stored on the storage, and we can see that is an hello from MQTT.
Yeah.
This refresh every 30 seconds, so it's going to keep all the information there. What else we could show? We already showed a deployment also locally. I guess we can also show, or you can deploy or you can bring your own infrastructure.
Exactly, with Kubernetes.
With Kubernetes. So let me just stop this subscriber and disconnect it, and disconnect also this one, and close a bunch of applications. So as I said, we have here a project that is called local, and we could see that the region is my laptop, actually, although it's not my laptop, it's a Kubernetes cluster that we have in the office. Which means that the way to bring the infrastructure is very easily. You can just click on your organization, on manage providers. You can create your own provider. For instance, we already created a Zetascale one. So let's imagine I want to create a Cloud platform. So call it GCP. We created this provider. This provider has no regions. So we need to add a region. We go to the region page and we say, okay, you know what? I want to add a region. So let's call it, I don't know, GCP EU. I will put a code GCP-EU, and there I need to pass him an icon that hopefully I have. Otherwise, I will just go to download a PNG. Icon PNG cloud. Images. Let me just get a PNG. This sounds like a PNG. Save image as cloud icon. Yep. So let's go there. Let's just get the okay, drag and drop. Let's just drop the file there. Okay, and now we click confirm, and we have the region that is created. So we can see still the region is down because we didn't start it. But what we could do, we can actually download the configuration for this region, and we get this zip file that I'm going to open on my VS Code. And let me move with called GCP. Okay, demo, code demo. Okay, and we can unzip it, and we'll see what there is inside. So what we have inside, we actually have a README, of course, as always, with the only command that you need to run in order to install this region. So in this case, the way we provide the region is by providing an Helm chart and the value files, which means that you can easily install this Helm chart in your Kubernetes cluster. So we provide instruction on how to run, on how to install Helm chart, and also on how to run the command. So let me actually switch to my Docker desktop Kubernetes cluster, so that I don't have anything installed. So an Helm list, I don't have anything installed, and actually let's install this guy. I will just run this command. This command is going to fetch, of course, what I did. I did something wrong on the regex, usual thing. I did put some dashes that were, yes, I cannot put this. There is another underscore somewhere. Okay. Usual demo effect, I picked the wrong name. So actually the way it works, and we'll see in a region where it's already installed. Okay. Clear. And let me make it bigger. And this we can remove, and this we can remove. Helm list. So once it's installed, we will see that the region is installed. So in this case, we have a Zetta region GB laptop that is installed. I know when it was installed, and actually we could see what the thing is running. And we'll see a bunch of pods that are actually, in this case, using, I say, some dog fooding to deploy on this region. So we have a region there running. Why we don't deploy on that region? So let's do that. So I say we have a project that is stopped. A stopped project means it's something for which you don't pay. There is nothing running on the infrastructure, but we keep some information. So like the configuration of the certification is still the same. So you can just stop and start without needing to change your configuration. We click play. And when click play, in this case, our platform is communicating with the cloud, with the Kubernetes instance running on our office. Yeah. It's actually downstairs through Zenoh. In this case, we are doing some dog fooding. And from that, we are deploying. And actually, we see that the router is just got deployed. So if you click there, we will see the router. But you may not trust me that the router is not there. But what I can do, I can just do kubectl get namespace. And we see that there is a namespace there that was created 24 seconds ago. And this namespace, actually, we'll see there is the router. Yeah, so we can see there. This Z something. This is our router that is actually running, and it got deployed from the cloud. But at a certain point in time, you could say, you know what, that was fine. Now I don't want to run this project anymore, and maybe I want to stop it because I did some demo, and then I don't need anymore for the time being. Maybe I will need it later. You can just stop it. And the deployment on your infrastructure can happen either through the platform, but let's imagine you're not using the platform, but you want to deploy directly from Zetta C2. You can also do that. So actually, let me connect like this, and I already have a Kubernetes cost test. So Docker desktop, and we had the router running in Docker. So let's remove that router because I don't want it. And now let's use Kubernetes. So what I could do now, I can take the same configuration that I used before, and I can deploy it on Kubernetes. Of course, I get a different model because I need to ask for different information. So it's called Zenoh local storage. Again, I can decide what kind of, how to expose the port, on which namespace to store it, to deploy it. So we'll do everything as default. Bam, the router is there. And I mean, we can already see because he already connected, but we can also see from kubectl. Yes. Bigger. We see that now there is Zenoh local storage, which is the router that we just deployed. Once we are done, also with this router, we could just simply delete it. And the router will not be there anymore. And this way, you can also, this shows that you don't need actually the platform to deploy on your infrastructure. You can also deploy on using the tool without needing actually to have a cloud infrastructure to deploy. Absolutely. You just need to have a Kubernetes cluster that nowadays can run even on robots, I will say. But of course, this is a very simplified way. This simplifies a lot the management of all the infrastructure for the users. Do we have time?
Yeah, I think we can take another couple of minutes. And by the way, something I want to make sure everyone understands.
Yep.
People can get started immediately with the platform, right?
Yes, indeed.
You can self-register.
You can self-register. You put your credit card, but sneak peek of the next features. We are also working on a free tier. Of course, it will come with few limitation compared to, let's say, the usual Zetta platform. But in that case, you will be able to get started even without needing a card. You will use a shared infrastructure but that will simplify.
But we'll unveil more.
We'll unveil more in the future anyway. But yes, so you can just get started and just put your credit card and deploy routers whenever you want, either on our cloud, either on your Kubernetes cluster.
Or if you are a company, I mean, we can create a corporate account and then you will get invoiced.
Exactly. Let's say the usual way.
Exactly.
I wanted to show some DDS stuff, so let's try to do it quickly. Okay, so I will start my Zetta C2, in this case connected to the domain 0, so which means I don't have any DDS application.
Yeah.
What I want to show is, actually I'm going to do that there and close this. Oh, so many things opened. Close this and this. So I'm going to use one of the usual demo that we use for DDS, that is DDS iShapes.
Yeah.
Oh, it's called Cyclone demo shapes. Zetta C2, in this case connected to the. Okay, so as I started the iShape, we already see that there is now one participant in my system, which is this participant 1, and we could see some information about the host, the process name, and the PID. And in this case, there is nothing to see because it's not publishing anything. So let's actually start to publish a circle with the default QS. And let's click publish. So now we are publishing a circle. So it was very fast. I click publish, and we could immediately see the circle appearing as a writer in this participant. And if we click there, we could get information. We can actually inspect the DDS, DSQS, or the DDS system. What else we could do is, okay, now we have one single participant. What if we start another one? And in this case, I want to subscribe to a circle. So quite easy. We see that the data is going through, and all of a sudden we get a matching. We see that there is a matching subscription, and we get all the information about the matching also for every QS. Let's say, for instance, reliability, we'll say, yes, this is reliable, and so on. And we can also see that now there are 2 participants, and for each participant, we can inspect what's happening. We can also see the list of in a graph view, so similar to the ROS graph, because it's called the DDS graph, and we see that there is this application that is publishing on Circle, and this application that is receiving on Circle. And the green arrow means that there is a match. I'm going to create a mismatch. In this case, I'm going to create a mismatch by subscribing on with, I click on the right one, yes, with the exclusive QS. So we see we are not receiving any data, and now we see that there is a red arrow appearing, because this means that there is actually a mismatch. But what kind of mismatch it is, that's very easy to check. Let's go to one of our participants, to our writer. Again, this case is the writer for Circle. And we see a little cross here on the ownership, which means that it's telling me maybe you have a QS mismatch, actually telling me to which DDS participant and which DDS reader I'm having a mismatch. This also shows that, again, we are integrating with DDS, it was seamless. We just started the applications, and if it just worked, and we are inspecting the system. But technically, we could inspect this system also remotely, which means that if we could use the tool per se as a bridge, bringing this information to the cloud, and this will help our colleagues. For instance, let's imagine you are a technician, you need to connect to a robot because something is happening. Yeah. But maybe you don't have the expertise of DDS. But with the tool, you could just bridge. The tool can be connected by cellular, by a satellite to the cloud or to whatever deployment. And from there, an expert could inspect the system remotely.
Yeah. Or even there are some applications which they don't allow remote debugging, but then on a remote debugging session necessary, they can just, as a matter of configuration in the tool, get cloud connectivity, and even us from our office, we would be able
to get and to inspect what's happening.
That shows your colleagues, whatever. Yeah.
Exactly. That shows the powerful of the Zetta platform, not only the tool, the platform as a service, the API, and everything.
Correct. Okay, I think we are done with it. So I would say let's summarize once again the key point, right? So Zenoh provides you the technological building block that solves the hard problem in Cloud-to-Microcontroller. It was designed to make sure that you can easily connect other protocols and storages, so databases, as well as easily have it run on multiple kind of networks and links, and that's essential. And then around all of this, we've built Zetta, where you get the platform as a service, commercially supported Zenoh, and also a Zenoh offering as well as Cyclone offering, right? If you are into DDS and also in Zenoh, with commercial add-ons such as tool and some other neat features. So if you want to learn more, just reach out. And I guess we'll close it here.
Yep.
So thank you, Gabriele.
Thank you,
Thank you,
Andrew.
everyone.
Thank you.
See you next. Bye.